So hi, this is me, Sadashiv, and my submission for the Aura Enterprise backend, where um, we are solving a problem of um, pagination, faster backend that has more than 50,000 plus SKUs, which are, required to fetch faster with this API. That's our basic goal. Um, so the key features of our backend for now are high performance query engine, right? Our query engine is paginated, filterable, and sorted access to 50 plus K items. So we do have seeded our MongoDB with 50,000 plus mock data, right? And yeah, we do have strict business validation that enforces business logic, like the price cannot be less than. I'll show you that in the API testing. Right, so this is the Node.js Express framework, and we have database as MongoDB and validation is used as Zod. So we do have the Postman collection. I imagined all the test cases that could be used for solving or representing the solution for the problem. Right. So yeah, that's about it from here. Let us go to the Postman now. So before that, I'll also show you that I understand that your team was managing 50,000 plus SKUs through Excel and SAPs, and the inventory page was freezing or taking 45 seconds to load, right? So our goal was back in the backend that could search, filter, analyze the entire catalog instantly without ever pulling the 50,000 records into memory at once. And to show you where did I feed the data, so here this is our Mongo database, MongoDB, where we fed the 50,000 SKUs. So now let us test the test cases one by one, right? So our first test case would be searching and pagination, right? So this is it. So you can see that the response arrived very fast, right? Where I set the limit 50 SKUs and the page was one. So yeah, the response arrived very fast. Only five records came back, even though there are thousands of matches, right? So we can count at it. So let's say if we want to limit it to five, we should get only five records, right? So you can see one, two, three, four, and five, right? That's about it. This is the server side search and pagination. The database does filtering, not the browser. So even with 50,000 products, the front end only ever asks for what it needs to render, right? Which is what keeps the dashboard from freezing, right? Next, let us go to sorting the price, right? So managers can filter by category and sort by price instantly because we index these fields, SKUs, category, products, products name. So these aren't full table scans, right? So let us run and see how response it comes. Next is analytics request, right? So this request gives us the analysis. of all the products, right? And we can see the response time is 122 milliseconds. So this is executive dashboard data, restock priority, inventory valuation by category, and the summary of KPIs. Right. Notice the response time, right? So we got it in under 122 milliseconds, which is very fast when compared to existing uh, method. So we are not looping through 50,000 records to in JavaScript to calculate this. This is a MongoDB aggregation pipeline. So the database does the heavy lifting. Now let us check the data integrity. Let us check for the create product. Let's say I want to add a new product. Okay, so body and if we update this as 1 2, there should be a product created, right? So we can see that the product has been added and our MongoDB should be updated with one more value over here. If I just refresh this, here we have the refresh. So you can see that the product has been added successfully, right? Um, that's it. The next case would be if the price is less than cost, then our request should fail, right? You can see that the price here is 45 and cost is 60. So our request failed. It returns a response that price cannot be lower than the cost, right? Next comes the negative stock. So if we look at the body, so let's say if we entered by mistake the negative value, they it doesn't accept and throws a 400 bad request error saying the stock quantity cannot be negative, right? So this is how we handle the edge cases as well. So same for the negative stock. The system protects the data integrity automatically, right? And these are the business rules, right? These three are the business rules trying to save a product priced below its cost and trying to save a product or the inventory stock if it was entered negative, right? The API rejects it immediately before it ever touches the database. So this is how we keep our database clean and persistent, free from any negative or any errors or any invalid entries, right? So this is where we check if there is an duplicate product exists, right? And we can even update the product as well from here. So all the CRUD implementation has been done. Uh, so we can see that the updated status is 200 okay, and let me show you like if we do it 180, let's say, even that should be updated again, right? So this will be updated in our database without any error, without any delay. So we can see that the time is 43 milliseconds, right? So to wrap up, the backend handles the search, filtering, um, and analytics across 50,000 plus records in well under our latency targets. So while enforcing your business rules automatically, it is deployed and live, ready for the front end to build the dashboard on top of it. So I've deployed it on the render. So this is the render URL that we can use directly with our front end team to connect this to our backend and have the problem solved. Thank you.